We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello friends, I hope you all are safe at home during this pandemic COVID 2019 and you are still learning at home. Myself, Assistant Professor Parth Danani from Civil Engineering Department, Silvera College of Engineering and Technology. I am also a chartered engineer and member of various structural organizations such as Indian Institute of Structural Engineer, GICA, ACCE, Indian Concrete Institute, and etc. As per the UGC guidelines, now it is mandatory to conduct an examination for the semester 8 students. So today I am here with the subject Design of Steel Structure, a very important subject for semester 8 students civil engineering. In that, today my topic is plate girder from concept to design. As you all know that now government has formed a rule for the timing of the paper, that is from 3 hours to 2 hours. So it is very important for the students to understand how the question will be asked. So if you understand the concept very well, then you can design any component very easily. So first of all, we will understand the component of or concept of the plate girder very well. Then we'll move to the IS code criteria of the plate girder so that you will better understand the design criteria. But before that, you will understand what is the plate girder, where plate girder is used, where you will see. If you see practically, yes, this is a plate girder and here it is used and these are the components of it, then it is very easy for you to understand or to design a plate girder. There are various chapters as per the curriculum of 8th semester GTU. Foot over bridge is there, plastic analysis is there, quantary girder, plate girder. So today we will understand plate girder, its concept. In subsequent lecture we will understand its design, and then in later on lectures we will understand various chapters. So what today we will learn is what is plate girder, history and background, where how the plate girder is evolved, application of the plate girder, advantages of plate girder in steel construction, components of plate girder, and design steps. So if you understand very carefully what is a plate girder, what is used, then applications, advantages, why it is more advantageous to certain other components, right? And then you will better understand the design steps. Directly if you move to the design example, then you will not able to understand the whole concept, because now the pattern is changed. The question is cut short. You need to understand the whole concept very carefully. So first of all, we will see what are plate girders. A plate girder is a type of beam built from plates of steel that are either bolted or welded together. Right, so that means a plate girder is a type of beam only. For example, you need to connect 2 steel elements. Suppose I sections are there. You are connecting 2 I sections with another I section. So this is known as the girder. A beam is a type of girder is a type of beam. It is a type of beam only from plates of steel that are connected, bolted, or welded. These are to be welded and bolted together. You can see over here. So plate girder are typically I-beams. They are typically I-beam. There are a lot of sections, the C channel is there, double channel section is there, like this, lot of sections are there, angle section is there, but typically they are I-beams made up of separate structured steel plates which are welded, bolted, or elevated. We have already studied this, what is welded, bolted. So there are the connecting criteria, how to connect that, right? With a pair of angles. So angles are being used to connect this all. How we are connecting? So here we are connecting an angle to it, right? To act as a compression and tension flanges. Now would you understand what do you mean by the flange, and what do you mean by the web, and all different components will understand in the later consequence slide. So now you can see, as I told you, first of all, understand the concept very carefully. In the previous slide, I have explained you that it is I section only. It is I section, which is made up of structured steel plate, right? So we are seeing the I section. So you can see in the I section, this is the overall flange width B. This is the overall depth H, which is also called capital D, right? Outstand width C, right? Web thickness TW, thickness of the flange. So there are many two components mainly, that is the flange and the web thickness of the web thickness of the flange in the I component. So it is very important to understand how the suppose this is my web of one I section, and this is the flange of another I which is connected to it. So how it has been connected? But is there any buckling, or how would be the strength of it? All some factors are there that you need to understand very carefully. If you understand the concept very carefully, that is very easier for you. So up till now, just two things remember, that is it consists of a flange and a web, right? So we need to understand how the flange would be. You can see over here also how it is been connected, right? So it is known as the root radius. This is here it is shown. It is known as the outstand leg, right? Connecting leg and outstand leg. This is like this. If it is connecting to something, it is known as the connecting leg, and which is separated is known as the outstand leg. Next we have now various examples are there. You can see over here. So this you can see here in the bridge. This is connecting, and you can see this is the girder. Yeah, this is the girder. This is the girder. So generally these are used for the railway bridges only, right? So we'll see later. History and background of the plate girder. In 1800, the plate girder were used in construction of road bridges. Plate girder replaced riveted and bolted plate girders. The purpose of plate girder is to build beam larger than anything that can be built by steel mill factories. So it is a larger thing, you know. When the length is too much large, we can use a plate girder. So simple. Plate means what? It is a simple plate. Element is there, and girder is the beam. Right. So simple plate, high section plate is known, maybe it can be called as a plate girder. The size and shape of the girder allows builders to construct structures that are much longer than heavier. So it is used to construct a longer structure. Oh, obviously, it is used for bridges, not for the construction of in steel building. Very rare. Plate girders are usually prefabricated to limit length frequently to by the mode of transportation. Right. Application of the plate girders, where the plate girders are used. Plate girders are usually used to construct bridges that are suitable for short to medium span and may support railroad, highway, or other traffic. Some of the important, most commonly used are where they are used. As I told you, it is a box bridge. One is in the box bridge, second is beam bridge, multi-girder, composite bridge, half-through bridge. Generally, these are used in the bridges. We'll not go detail into which type of bridges are there. That is the latter part of it. Design of bridges, it all comes. But these are generally where it is used. Now next, now we can see where it is the different bridges. So at this bottom, this is the girder. You can see this is the whole girder going on, and here this is the girder going on. This is a whole example of the fill bridges that we are. Now beam bridges, you can see this is a this whole section is a girder. Now there are something like this. You can see over here. What is this? These are known as the stiffeners, right? So there are longitudinal stiffener, transverse stiffener, because the load is coming onto it. If the concentrated load is coming onto it like this, it might bend. So if it bend like this, you require something stiffener. Stiffener is what? एक ऐसी चीज जिससे वो एकदम स्टेबल रह सके, that is known as stiffener, you know. So how many type of stiffener are there, where it is to be used, that we will see in the consecutive slides. So again, a very beautiful picture you will see. Again, this is the girder. From the bottom view, we can see these are the girders going on, right? These are the girders. These are the girders. So generally used for the bridges. Again, very important. These are the girders. These are the girders. These are the girders. Plate girders talking about. So one of the tallest bridge we are talking about, not the longest, tallest bridge, Millau Bridge. If you have time, you search on it. What is the Millau Bridge? Millau Bridge is also having the same concept of it, where plate girders are used. Bridges using plate girder. Again, you will see. This is the plate girders, right? So from different example, it is now clear to you, okay, where plate girders are used. So this is, you can see the whole construction. When it is constructing and this is after construction, this is a plate girder going on, you can see throughout, right? Advantages of plate girder in steel construction. So its feature, but the feature is simple, provide convenient transport. It can be transported very easily. Speedy erection is there. Heavy loading capacity, it can have a huge load, because of especially it is used for the construction of railway bridges where the load is very high, in a lot of tons. So it gives very great stability along fatigue life. It has a great stability over compared to stability of overturning, being capable of alternate span loading capacity, right? So now this is a real picture of it. What we will see, this is the eye section like this. And these are, you can see, intermediate. What you see, these are the stiffeners. So if I draw the 3D figure over like this is the eye section, which is lying like this, and the intermediate stiffeners are over here. This is the 3D view I'm drawing. So what you see, these are the intermediate stiffeners. And now what are the stiffeners? What are the components that you will understand in the subsequent slides. Now what are the important components of the plate girder? There's a web plate, flange plate, flange angle, web splice, flange splice, longitudinal horizontal stiffener, transfer vertical stiffener, bearing stiffener, and bearing. So that very important is web plate, flange plate, longitudinal horizontal stiffener, transfer stiffener, bearing stiffener, and bearing stiffener. So generally you need to design this web plate, flange plate, and you will design a lot of stiffeners, maybe horizontal, vertical, transfer, which type of stiffeners are there that you need to design. Right. Now what is the web? You can now see over here, the deep central vertical plate is called as web in a plate girder. This is a web, you can see over here. This is a web. It separates two flanges. This is two flanges. It separates out by a required distance. The web is responsible to resist shear developed in the plate girder. The shear force which is developed, it is responsible because ultimately the load is coming onto the web. So that the thickness of the web is very important. If the thickness is very less compared to the thickness of the flange, then it might buckle, it might shear, right? Local buckling may occur. You need to check whether the stiffeners are need to be provided or not. Now next is flanges. Flanges or flange plates are horizontal elements of the plate girder which are provided at the top and bottom, and they are separated by the web. Again, as I said, we know it, the main purpose of the flange is to resist the bending moment acting on the girder. So this is the flange. So main is what? The bending moment which is acting, the main purpose is what? The top flange resists the bending moment by developing compression on the bottom flange, resist by tensile force, right? So this is by compression and this is by tensile force. It gives another opposite reaction so that it will be stable. They should be provided with the required width and thickness to offer good resistance against bending moment. Yeah, it is also very important. Now, as I told you, very important part, stiffeners. What are the stiffeners? So, the stiffeners are what? And they are classified into horizontal stiffeners and vertical stiffeners. You can see horizontal stiffeners and these are vertical stiffeners. Both are provided, depend on the situations, right? So, hope you understand what stiffeners are. From the figure, it is very clear to you. Now, when it comes to design part, you will better understand how the stiffeners are and how you need to design it. Vertical stiffeners are provided right angle to the flanges and they are also called transverse stiffener. Vertical stiffeners are provided to the right angle to the flanges, so they are known as the transverse stiffeners too. The main purpose is resist bending moment acting on the girder. they again classify into two types, namely end stiffener and intermediate stiffener based on the position of the plate. Yeah, so if it is at the end, vertical stiffener at the end is known as end stiffener, and these are known as the intermediate stiffener. Intermediate and end stiffener, depending on the type of the loading we have. End stiffener provided both the end of the girder. They receive the load from the beam and transfer it to the support. In plate girder, some part of the end portion of the web is subjected to compressive load. Due to this load, the section may get crushed. So it might happen that the web may crush. Hence, the end stiffener play an important role by keeping the web safe from crushing. End stiffener are known as bearing stiffener. So end stiffeners are what very important. They can keep the intermediate stiffeners are required when there are concentrated load acting on the plate girder. Right, so intermediate stiffeners when are required where there are concentrated load, means the load is at a particular point, you know. So these are the intermediate stiffener you can see over here. When there is a concentrated load at a particular point, we require this type of intermediate stiffeners, while the end stiffeners are required so that the web will not have that much of compression or crushing. Web will be safe. That's why the end stiffeners are required, and intermediate stiffeners are required when there are concentrated load on it. Right, when the thickness of the web is less than 1/85 of the depth of the web, then web may buckle due to shear. As I told you, the web is there, if the load is coming, the web may buckle due to shear. If less than 1/85 the depth of the web. So these are the criteria which is given in the IS 800/2007. In that scenario, intermediate stiffener provided in order to improve the buckling strength. So the basic reason we provide this word in order to improve the buckling strength of the web. Right. Next, horizontal stiffeners. Yeah, we talk about now vertical stiffeners. These are the vertical. Now these are the horizontal stiffeners. Horizontal stiffeners are provided provided in parallel to the flange. Right. So this is suppose this is the flange. Horizontal stiffeners are provided like this, parallel to it. Vertical like that. This is parallel to the web, and this is parallel to the flange. They are also called longitudinal stiffening. Important to know. Vertical are known as the transfer. Horizontal are known as the longitudinal. These stiffeners improve the buckling strength of the web portion. Horizontal stiffeners are either continuous or discontinuous, right? What do you mean by continuous? So like this horizontal stiffener may be continuous from year to year, or it may be discontinuous. Connect all the transfer stiffener and take load coming from the flange and web portions. Or it connect all the transfer stiffener that coming on taking the load from the flange and the web. Discontinuous stiffeners, horizontal stiffeners are provided between the transfer stiffeners without touching them. They do not take any load coming from the flange or web portion. They just provide buckling resistance to the web. Right. So discontinuous stiffeners are not are provided between the transfer stiffener without touching them. Transfer stiffener provide without touching them, just to have the buckling strength of the web. Right. So these are in a simple way: horizontal stiffener, vertical stiffener. Horizontal are known as longitudinal stiffeners. Vertical are known as the transfer stiffeners. Horizontal stiffeners may be continuous, discontinuous type. Vertical stiffener, end stiffener, intermediate stiffener when the load is coming, and stiffener in order to have the buckling strength of the web. These are the small things that you should know. Now again, very clear from this, you can see over here, this is the transfer stiffener, this is a longitudinal stiffener, right? In the real figure, this is a real example. These are the stiffeners. We have only vertical stiffener, we don't have transfer stiffener. If I provide a stiffener like this, it's known as transfer stiffener. So in a design, the important is if you analyze the load is coming onto it like this, then you provide this stiffener. So you need to analyze first how the load is coming, and what is the distance between these all stiffener. That is also to be understood. I guess criteria is there for this too. Now you can see how the these are being connected to it. You can see over here. Stiffeners are required when factor concentrated load or reactions of plate girder are resistant to plate girder. Failure due to concentrated load and local buckling of the web in the region Again, the same thing where the stiffeners are provided. Transfer stiffener has insufficient strength, support concentrated point load, then a pair of transfer stiffener to be added to the web transfer concentrated load to the web. Now these are the transfer stiffener. You can see a very real example of it. If you see the real example, it is very clear to you. Right? Okay. Oh, we jagya how to provide karma how to do like this. So you understand because engineering, civil engineering is a practical exposure. In a later subsequent slide, you will see in some software also, design of plate cutting software. So this is the transfer stiffener. Bearing stiffeners, these are bearing stiffener are provided over the end bearing of the welded plate girders, over the intermediate bearing of the continuous plate girder. They consist of two or more plates placed on both sides of the web. See, two or more plates are connected on both sides of the web. These are known as the bearing stiffener. Bearing એટલે કે એ સહન કરે છે. It is bearing the load. That's why it is known as the bearing stiffener. Welding procedure, how it has been welded during the fabrication. Welding of the girder has been done in the different phase. Fillet weld of 8 mm. Very important how the welding is done. Placing of the web plate over a platform. You can see this is now the plate is this is the plate which is being placed on the platform. Flange is being placed by side web. You can see now how it is being placed. Welding a U-shaped plate to the web. Now this has been welded. You can see the welding has been done. Welding of inclined rod to keep web and flange perpendicular. You can see the welding has been done. You can see the welding has been done. Right, now we'll see one video which will give you a clear concept what we have done up till now. In very quickly we will see this concept. You can see the two eye sections are there. Which are being connected to it. Now how they are connected, that we will see. The whole concept, how the welding has been done, what is the intermediate stiffeners are there, transfer stiffeners are there. You can see now the intermediate stiffener. These are the intermediate stiffener. Vertical stiffener. How the welding has been done over here. At the bottom also you can see so here the bolting has been done by a plate, angle plate. So how it is been done is just you need to just have a clear picture in your mind. So that you will understand better. Yeah, so what we have seen in this, all the components, what we have studied up till now, that is how to connect the two plates, eye section, how the eye section will be connected, where the plate girders are used, and what is the intermediate stiffness, what is the transfer stiffness, what is the flange, what is the web, what is the criteria, how the buckling of the web can be resisted. That all we have seen in that small video. So now I think the concept is clear. As I told you, okay, we have now software known as Tekla structure. You can see over here in this, okay, how it is been connected. So you will see subsequently you will see over here. You can see over here there is a software known as tech structures. In that tech structure, you can see the connection over here, how it has been connected, right? How the connection has been done. That is very clear over here. So you can see the connection over here. Here, therefore, the bolted connection. So I section, you can see this is the I section, right? So here another is been connected. So this is the known as the flange. Right, that is the web. In order to don't have the buckling of the web, the various type of stiffeners are provided. This is what the criteria is, right? So this is where the basic concept regarding the plate girder, how the plate girders are used, how they are connected. So in designing, what will be the important factors that we will consider? So one thing is very clear. We will see the thickness of the web. We'll first of all design this section of the I section, that is the thickness of the web, thickness of the flange, and total D. So we'll first of all we'll have this condition. After that we'll check this condition whether this condition is sufficient for the buckling criteria for a different loading condition. Depending on the load, we will have a bearing stiffener and bearing stiffener and that sort of thing. So this is an overall idea about what is the plate girder, right? In the subsequent lecture we will understand about how the design of plate girder has been done, and what are the things that can be used in designing of plate girder, different IS code criteria. If you understand this very carefully, you can have a designing very easily. So this is my contact number and email ID. If you have any doubt, you can just ask me and mail me on the email ID. In some next lecture we'll see the designing part of it. As I told you in the starting of the lecture that now it is very important to know how the question will be asked. So it is not the whole design that will be asked in the 2 word. It is a cut short design. So if you understood the very concept very carefully, then only you can do it very easily, right? Because the design step involved a lot of steps. So if you know, okay, yeah, the loading, if the loading is concentrated load, then we have to design for the bearing stiffener. If it is not a concentrated load, then we have to go for intermediate stiffener. So like this different condition you should know. Based on that, you can have your designing smoothly. So I hope you understand the basic concept of plate girder, where plate girders are used, and what are the different components of it, and what are the criteria that can be in the IS 820-2007. So thank you very much. In our next lecture, I will be back with the designing part of plate girder. Thank you. Have a nice day. Stay home, stay safe, and keep learning. Thank you.